Bismillahirrahmanirrahim. My name is Ikra Ijaz. I am doing MS Chemistry from UMT Sialkot in the supervision of Dr. Hammad Majeed. My presentation topic is energy storage devices. First, we will see the content of this topic: introduction, characteristics of energy storage systems, types of energy storage systems. First one is batteries, second flow batteries, third electrochemical super ultra capacitors, fourth hydrogen storage, fifth thermal energy storage, in short TES, sixth flywheels. Introduction: energy storage is accomplished by our devices or physical media that store some form of energy to perform some useful operation at a later time. Yes, of course, because we are going to generating energy, so either we are directly using that particular energy, but it's not possible every time that whatever the energy we are generating at a time, we are able to utilize that whole energy. No, that extra energy we have to store. The energy storage, along with renewable energy generators, photovoltaic, is required to increase reliability and flexibility. The intermittent nature of renewable sources like solar and wind needs storage to deliver the right amount of power at right quality. Basically, you can see in daytime we are getting the solar or maybe that sunlight. That time we are generating huge amount of solar energy, but it's not that every time. We need that particular energy into the daytime. We have to use that particular energy into the night time. So how we can do it? That's why whatever the energy we use generating into the daytime, you are storing particular energy, either maybe some batteries or maybe some kinds of energy storage devices or maybe like supercapacitors. It is used to accommodate the projected high penetration of solar and wind energy in future grids with lower grid rejection loss. Characteristics of energy storage systems. First, storage capacity. Storage capacity is nothing but the quantity of available energy in the storage systems after charging. Second, available power, expressed as an average value as well as peak value, often used to express the maximum power of charge or discharge. Third, power transmission rate, time needed to extract the stored energy. Fourth, efficiency, defined as WUT over WST, where WUT is the energy utilized while WST is the energy stored. Fifth, cycling capacity, durability, number of times the storage unit can release energy level it was designed for after recharge, expressed as the maximum number of cycles n. Sixth, autonomy, the maximum amount of time the system can continuously release energy, expressed as A is equal to WUT over PD, where PD is maximum discharge power. Seventh, feasibility and adaptability to the generating source. Highly efficient storage systems need to be closely adapted to the type of application and to the type of production. Eighth, characteristics of energy storage system is self-discharge. Portion of stored energy dissipated during non-use time. Ninth, mass and volume density refers to the maximum amount of energy stored per unit mass of the storage system. Here we will see different types of energy storage systems. Energy storage systems, first one is electrochemical. Electrochemical energy system is realized by electron and ion charge or discharge. Basically, it typically divided into batteries, flow batteries, fuel cells. Electrical. Can be divided into further capacitors, supercapacitors, superconducting magnetic energy storage, in short SMES. Third, chemical. Chemically, it is divided into hydrogen storage system, biofuel storage system, hydrated salts. Fourth one is thermal energy storage system. Thermal energy storage is another method for adjusting the time discrepancy between power supply and demand. Excess thermal energy is stored in a material as sensible or latent heat by warming or melting the material. The thermal energy utilized later by cooling the material back down. Basically, it is divided into molten salt, solar ponds, cryogenic liquid air, or nitrogen. Here, last one is mechanical energy storage system. Mechanical energy is carried out by conversion between electrical energy and mechanical energy at demand. When inexpensive of peak electricity power is available, electrical energy is stored by converting into mechanical energy. The stored energy is released when the electricity power supply is insufficient. Mechanical storage system can be divided into flywheels, compressed air energy storage, in short CAES, pumped hydroelectric storage. First, then we will discuss about batteries. Batteries store energy chemically and uses electrochemical reactions to produce electricity at a fixed voltage. Batteries are suitable for applications that require the supply of relatively large amounts of energy storage, more than 1 megawatt of hour, over long periods of time, 15 minutes or more, where rapid recharge is not necessary and where maintenance can be reasonably performed. They are not especially suitable for environmentally sensitive sites, remote locations, or applications that require rapid discharge and absorption of energy. Here some advantages of batteries are convenient voltage characteristics, have convenient sizing, have extensive design history. Some disadvantages of batteries are limited cycles life, voltage and current limitations, and have often present environmental hazard. Flow batteries. A flow battery operates by passing a solution over a membrane where ions are exchanged to charge or discharge the cell. Its storage capacity is a function of the volume of the tanks holding the solution. A flow battery is technically similar to a fuel cell and an electrochemical accumulator cell. Commercial applications are for long half-cycle storage such as backup grid power. Here's advantages of flow batteries are have flexible layout, long cycle life, no harmful emissions. Here some disadvantages of flow batteries are need large tanks to store energy, low energy density, low charge and discharge rate. Electrochemical super ultra capacitors. Electrochemical capacitors, in short EC, also known as supercapacitors, ultra capacitors, electrical double layer capacitors, in short EDLC. They store energy in the electrical double layer at an electrode or electrolyte interface. The energy and power densities of electrochemical capacitors fall between those of batteries and conventional capacitors. Here are some advantages: high power density, high cycle life, quick recharge. Disadvantages: low energy density and it's so expensive. Here, hydrogen storage. Now, amongst different sources, hydrogen has been recognized as an ideal energy carrier and environment friendly energy source. We have different methods to produce hydrogen energy, and most efficient way to store energy is in chemical form. Compared with liquid and gaseous state storage, solid state is very reliable method because of safety considerations and volumetric capacity. Advantages of hydrogen storage system is abundant in earth crust and capability of hydrogen with fuel cell, high efficiency 65% than diesel 45% and gasoline 22%. Disadvantages of hydrogen storage system have high cost, highly flammable. It is still dependent on fossil fuels. Thermal energy storage system. It is defined as the temporary holding of thermal energy in the form of hot or cold substances for later utilization. TEM systems deal with the storage of energy by cooling, heating, melting, solidifying, or vaporizing a material, and the thermal energy becomes available when the process is reversed. TES systems are used particularly in buildings and industrial processes. Advantages: helps to cut down electricity bill, green building, high versatile and environmental impact is reduced. Disadvantages: energy lost in round trip inefficiencies, additional cost and complexity, additional infrastructure and space requirements. Last one is flywheels. Flywheels store energy in the form of momentum in a rotating wheel or cylinder. An electric motor spins the rotor to a high velocity to charge the flywheel. During discharge, the motor acts as a generator, converting the rotational energy into electricity. Power electronics are used to ensure that output voltage has appropriate voltage and frequency characteristics. Advantages of flywheels are high power density, high cycle life, power, and energy sizing. Disadvantages of flywheel have low energy density, large standby losses, potentially dangerous failure modes. Thank you. This is all about from myself.